most of this will be a review of what we were doing before we started working on the TSIA. We started working on exponentials and logs, and then we took a break to work on the TSIA stuff, and now we're going back to the exponentials and logs. And so you're going to open your book up to the first, well, I labeled this one page 1. So open it up to page 2, and on page 2, you're going to draw a line down the middle. And we're going to do 2 examples. This is the page that says exponentials, no logs at the bottom. Now, actually, these are not both exponential. This is an exponential equation. This is an equation with an exponent. That's not exponential. This one is not exponential. This one is. Why is this one exponential? Why is this one not exponential and this one is exponential? Right here, the x is the exponent. That's what makes it exponential. And we learned to change this to the same base. So if we're going to change this to the same base, get back over here to my chart. So we have the 4 and the 8 right there. So what base are we going to change it to? And so we are going to change this problem to base 2. 8 is 2 to the 3rd power. 4 is 2 to the 2nd power. This has an x. The bases are equal, so that must mean the exponents are equal also. Divide by 3, and x equals 2/3. You can check it by putting it in your calculator. 8 raised to the 2/3 power. If you're checking it with your calculator, you must have a parentheses around the 2/3 power. If you put that in your calculator, you will see that it is equal to 4. Now, on this next one, that the x is the base. It's not the exponent, the x is the base. So I need to solve for x, so I need to get rid of this 4th power. How do I get rid of a 4th power? It would be true that I would square root it if this was a 2. Since it's a 4, you could actually square root it twice. But I am going to show you the way to get rid of any exponent, not just a 4 or a 2. You use the reciprocal power. What is the reciprocal of 4? So I'm going to raise it to the 1/4 power. The power times the power rule says that those multiply together. 4 times 1/4 makes 1. That's x to the 4th power. This you put into your calculator. You raise it to the 1/4 power. You have to put parentheses around the 1/4 in order to get the correct answer with your calculator. What is the correct answer? And you can check it by putting it in the calculator. 6 raised to the 4th power in place of the x, put the 6. Does that equal 1296? What is the title of page 3? Okay, so now we're going to switch to our definitions. And so All of these definitions need to go on page 3. The first definition up here is what we started with logs, how to change from exponential to log and log to exponential. The log is the inverse of the exponential. Please copy this on page 3 of your notes. On page 4, please draw a line down the middle so we can put in 2 examples. The title of this page is log equals to log. If the log equals to the log, it's like the log part cancels out, and you just solve 8x plus 20 equals x plus 6. As if the log base 7 canceled out. Now, it does have to have the same base. So, all you have to do is solve that. Subtract the 20 from both sides. Divide by 7. Do you remember that kind? That was easy. But this one over here has a number in front of the log. It's not simply a log base 5 equals another log base 5 because this number 2 is out in front. So I have to get rid of this number 2 using the power rule. That's one of the rules you wrote down over there on the page with definitions and rules. So this number goes back over here as a power. That's what the power property or power rule tells you. Number out in front goes to the back as a power. Now I have a log base 5 on the left, a log base 5 on the 6, on this side, and nothing out in front. So that means x minus 6 equals to 4 squared. What is 4 squared? Add 6 to both sides. If you have a log equal to a log, it's pretty easy to solve that. Next, page 5 of your notes. On page 5 of your notes, write these steps down at the top part of your paper above the fold. Write this part on this 2 steps. Write your 2 steps above the fold on your paper, and then we'll have room for our 2 examples on the bottom. In order to solve this problem, I am going to isolate the log and then change it to exponential form. I could use the power rule and bring the 8 back here as a power, but that's going to mean I've got to raise it to the 8th power, and then I'll have to get rid of an 8th power. It's easier if I divide both sides by 8 and cancel out the 8. Log base 2 of x minus 3 equals 1/2 or 0.5, whichever way you want to write it. Do you remember how to change it to exponential form? This is the base, this becomes the exponent, and that's what it's equal to. 2 is the base, 0.5 is the exponent, and that's equal to x minus 3. Now, 2 raised to the 0.5 power does not come out to be a beautiful number. It's going to come out to be a decimal number, and on these log problems, we typically round to 4 decimal places. It is traditional to round to 4 decimal places. A lot of times when you're using these are scientific type problems, and you need a little bit more than the usual 2 decimal places. To finish solving, add 3 to both sides. And so 4.4142. Does everybody know where I got that number right there? I put 2 raised to the 0.5 in my calculator, and that's where this number came from. Did you try it out for yourself? Step number 1 says to isolate the log. What am I going to do with the 7? Not divide it. Subtract the 7. The opposite of add is subtract. Log base 6 of negative 6x minus 4 equals 2. Then I'm going to change it to exponential form. Base exponent equals this. 6 is the base, 2 is the exponent. It's equal to this. What is 6 raised to the 2nd power? What am I going to do with the 4? Divide by negative 6. Reduce to lowest terms. Not decimal. Lowest terms. Now, all these examples so far are what we were doing before. None of this is new. Now we're getting ready for the new type of problem. But before we do the new type of problem, let me go back to a previous page. Back here on page 2. How did we do this first problem on page 2? We find the same base? Isn't that what we did? You changed it to base 2? But suppose instead of that, instead of this being a 4, suppose this had been a 5. Would we have been able to change it to the same base? No. So does that mean I can't do the problem if it has a different base? Well, I can't. And that's why we need a change of base formula. I'm going to change it to base 10. Why would I want to change it to base 10? That's the base that the calculator has. Remember me telling you the only kind of base you could do with the calculator is base 10 or base E, and we aren't even do base E in this class. So we're going to change it to base 10. Now, the calculator can only do base 10, but what I didn't tell you at that point is, if it's not in base 10, I can change it to base 10 because I know the change of base formula. So on your paper, you're going to write the change of base formula on the next page in your notes. Yes, at the top of page 6 above the fold. Yes. To put this in your calculator correctly, you must close the automatic parentheses. Pick up your calculator and put log 7 close parentheses divided by log 25 close parentheses. The number goes on top, the 25, the base goes on the bottom. That's what this is telling you. The big number on top, the log of the base on the bottom. This has no base number. So what is the base? 10. If you put that divided by that, you didn't get this number. You got some more decimal places. And this is the rounded off number. Uh, 25 raised to the 0.6045 power isn't actually equal to 7. It's approximately equal to 7 because this number has been rounded off. And it doesn't come out exactly, because this number has been rounded off, okay? When you put this one in your calculator, when you put a log problem in your calculator, you will not get the right answer if you do not close that automatic parentheses. And then you close the automatic parentheses, and what do you get if you put that in the calculator? You don't get undefined number. You get an error message. And what that error message means is this is undefined, because way back when we started logs, we learned that you could not take the log of a negative number. You cannot take the log of a negative, with a negative base, I should say. I said it wrong. You can't have a negative base. And that's why it's undefined. So if you did not finish writing, what happened to my steps? There they are. If you did not finish writing your steps, please do so at this time. On the bottom half of your paper, draw a line down the middle and put these two examples. So, I am going to use my calculator to calculate the answer here on this problem. So, the way the change of base formula works is the log base 10 of the big number divided by log base 10 of the negative 2 number. I don't put in the 10 because if the base is not written, the base is 10. You must close the automatic parentheses. When you put that in the calculator, you get an error message because this is a negative base and that is undefined. That error message means undefined. So, next example. This is the kind of problem that really is useful. The change of base is very useful to solve. I am going to take the log of both sides. Just a notation thing, you must put the log word in front of the number. You cannot put the log word after the number. That is incorrect notation. Now, one of those rules we wrote down back on the definition and rule page was the power rule for this kind of problem right here. This power comes out in front. The x comes out in front by use of the power rule. Now I need to solve for x. What do I need to get rid of? The log and the 15. Now what you need to know about the log and the 15 is they are glued together. They are glued together with log glue, and log glue is even stronger than adding glue. And they cannot come apart. The log and the 15 are stuck together. And so I need to cancel them out together. So x is equal to log of 20 divided by log of 15. And you must have the parentheses in there to get the correct answer. And so log 20 close parentheses divided by log 15 close parentheses, x is equal to 1.1062, rounded off. By the way, this is not the same as log of 20 divided by 15. That is not the correct way to put it into the calculator. Some people try to shorten it by leaving out the logs. That's not what the formula says. So we will have to do the rest of our examples next time.